Greetings everyone, welcome back to Trigonometry. Professor Simon here, ready to finish up the graphs that we're going to talk about of the main trig functions. Today, tangent and cotangent function graphs. Now, these don't have as nice of a connection to sine and cosine that secant and cosecant did. However, they are somewhat connected because I can use the quotient identities for these. Okay, but let's go through some basic properties that we remember. Tangent of 0 is 0. Tangent of 90 degrees or pi over 2 radians is undefined, right? Tangent of 180 degrees or pi radians is 0. And tangent of 270 degrees or 3 pi over 2 radians was undefined. So then you can see the repetition on and on and on. But of course, it also should go in the negative direction. So if I rotate down to negative 90 or negative pi over 2, again, you'd hit that 270 line and it would be undefined. Okay, so typically what we do is we count a period between the asymptotes of these guys. And notice what that gives me is a natural period of pi, not 2 pi. The other four that we've talked about have a period of 2 pi. Tangent and cotangent have a period of only pi. Okay, so in a minute when we start drawing these, I'm still going to do the period and the quarter period, but the period and quarter period are going to be based off of one section in between the asymptotes here. Okay, the other thing to remember is that tangent starts at 0. So if I'm going to graph in between the asymptotes for just tangent, when I draw my 5 marks, my actual center is in the middle mark, not on the end one, okay? However, for cotangent, notice that cotangent has an asymptote at 0, and it goes through 0 at pi over 2. It's exactly the opposite of tangent, okay? So with cotangent, the first mark that I'll put will be the 0 mark, okay? That'll be my first spot on that one. Okay, so then the other thing to note on these is whenever I'm graphing these, I'm going to be doing quarter periods, which means I'm really going to get some marks that are in between here and here. This is pi over 4. And the only really importance there is, remember, the tangent of pi over 4 is 1. So if this is negative pi over 4 here, then that spot right here will be at negative 1. That's sort of like an amplitude. Although with tangent and cotangent, they don't have a peak or a turn or a crest of any kind. So it's not exactly the same. But if you had to have something like an amplitude on these, just like the other four, that would be it. It would be where this quarter mark is, how high that is. So if I have a higher amplitude, the tangent will tend to more straighten out. And if I have a lower amplitude, it'll tend to flatten out the swoosh on these things, okay? But that's about it. When I get my quarter marks in there, I'll be using those as amplitudes, okay? And then of course the domain and range is going to be very similar to the ways that we were talking with the secant and cosecant. Obviously my domain is going to be sectioned with asymptotes, and I'll have to do a counting type of domain. But the range on both of these graphs, as you can tell, just one swoosh goes through the entire range of y values. So on both of these, the range is negative infinity to infinity. Okay? Some other little snippets. If you wanted to draw, say, a cosine on your tangent, that would help you see where your asymptotes are. Your sine would be where your zeros are, right? Cosine would be 0 when this is an asymptote. But the reason why I don't draw them on there is because the shapes of sine and cosine don't naturally lend themselves otherwise to the shapes of the tangent and the cotangent. Whereas with the secant and cosecant, the way they meet up is really nice. So typically with tangent and cotangent, I just try to just remember the shape. You know, tangent increases, cotangent decreases, unless they're reflected, right? Tangent starts in the center, cotangent starts on an end because it's at 0 right here. Okay, just those little things right there is enough, as long as I remember that the period is pi, and then I find the period and the quarter period and count it out. It's pretty much the same graphing technique after that. Okay, Let's go get some examples. So let's do these 3 examples to sort of sum up this whole section here. Okay, so I've got 2 times tangent of 5 pi over 7x. So obviously I've got a period change because I've got a frequency number here. And then I've got an amplitude change on the tangent, making it a little bit taller. Let's start by calculating the period. So the period here is going to be pi divided by 5 pi over 7, which is going to give me 7/5 because I'm going to flip this and multiply, right? And the pi's are going to reduce, giving me 7/5 as my period here. That means that my quarter period is 1/4 times 7/5 or 7/20. So I'll be counting quarter periods with 7/20. All right, so let's start by putting down my marks here. I've got my x-axis, and I'm going to put 5 marks down. Okay, now here's the thing to remember. Since it's tangent, tangent is the one that starts in the center. The center of tangent was 0. It has not been shifted. So the center number is still 0. Each quarter period is 7 over 20. So that means this is 7 over 20, and this is 14 over 20. This would be negative 7 over 20. This would be negative 14 over 20. And then, of course, again, if you want more periods, you count more marks and you can do more 7 over 20 jumps. The way tangent works is this is my center, so then the 2 outer marks are my asymptotes. So I would draw asymptotes here and here. Since this is 0, that's my y-axis. Right? And I have an amplitude of 2, so I'll go ahead and just label that. Okay, now remember the way tangent works is it goes through the center. So that would be here. And then on the quarter marks, it's at the amplitude. So that would be here and here. Beyond that, it's got to hug the asymptotes. So my tangent is going to go up. It's going to go through these 3 marks. And then it's going to hug again. Okay, now yeah, it looks kind of real sloppy here. But what you have to remember is it starts really seriously hugging this asymptote right here and way right here. Okay, my scale is just a little bit tall, but also an amplitude of 2 for a tangent makes it really tall. Okay, so my tangent tends to look taller with that piece like that. And that would be 1 cycle of this tangent function, right? The range is going to be all real numbers. And then my domain is going to be such that x cannot be, let's start with 14 over 20. And then how far is it between these two? Well, nice thing for tangent is the distance between asymptotes is the period, 7/5. So I would say plus 7/5 times n, and n can be any integer. Okie dokie. Next one, cotangent. I notice that there's a shift on this one. So I'm going to start by rewriting it in that proper form that we're accustomed to using. Okay, so I've got g of x is 1/2 cotangent. I'm going to factor the 2 out. That's going to give me x plus pi over 6. Remember, you do the factoring by dividing. Pi over 3 divided by 2 is going to give me pi over 6. If you're not sure, do 2 times pi over 6. You'll notice you'll get pi over 3 back. Okay, so that means that I have a shift to the left of pi over 6. And I can now do my period using the 2. So let's start with the period. Okay, so my period is going to be pi over 2. Just pi, the original period, and then divide by the frequency number 2. Okay, so I've got the period. The quarter period is going to be 1/4 times pi over 2, which is going to give me pi over 8. All right, now remember, my shift is pi over 6 to the left. Okay, don't forget, this is left. And then my quarter periods are pi over 8. That's what I'm going to be counting by. So I need to get some common denominators going on here. Okay, for pi over 6, for this shift, I'm going to use negative pi, not negative pi, negative 8 pi over 48. Actually, I can do better than that. 6 and 8 both go into 24. Let's do 4 over 24. That's my shift. That's why it's negative, because it's to the left. And then my quarter period here, I'm going to use 3 pi over 24 as my counters. Okay? Now this is cotangent. Cotangent starts on an edge, right? The beginning of cotangent in the center of the grid at 0 was an asymptote. So the first mark I put down this time is going to be my start. Okay, tangent's the only one that starts in the middle. So here I go. Here's my x-axis. I'm going to put 5 marks on here. My edge right here is my shift. That's negative 4 pi over 24. Right? That's the negative pi over 6 shift. Now I'm going to keep adding 3 pi over 24 every quarter jump. So then that's going to be negative pi over 24, then 2 pi over 24, then 5 pi over 24, then 8 pi over 24. Those are the quarter periods that I'm jumping there. And again, cotangent starts on an asymptote, ends on an asymptote. So that's where my asymptotes will be, here and here. Okay? My axis is going to be somewhere in between these two, because that's the negative and positive switch over. That's not the center of my graph anymore, but I need it for the scaling, right? My amplitude is 1/2. So if I mark this as 1, 1/2 will be here. So then this will be negative 1, so negative 1/2 will be there. Give or take, right? Freehanding this thing. All right, so cotangent decreases. I'm going to start up here, and I'm going to go this way. It's going to go through the center mark, and on the quarter marks, it's going to hit the amplitude, which is going to be here and right in the middle of the 5 pi over 24, right here. So I'll go ahead and relabel that one up here, 5 pi over 24. All right. So then here's my cotangent graph. It's going to hug, and then it's going to start swooshing, and then it's going to hug again. That one came out a lot better. Okay? And then, of course, the domain and range work very similarly. So my range is negative infinity to infinity. That's cotangent and tangent. Domain is going to be where x cannot be. I'll use the 8 pi over 24, which is what, pi over 3? Yeah, 8 pi over 24 is pi over 3, plus the distance between asymptotes here is a period. So that's pi over 2. So plus pi over 2 times n. And then, of course, qualify your n as any integer. Okay? One more example. I have 2 minus tangent of 3x minus pi over 4. Let's rewrite this in a way that you're familiar with all of the pieces. So I have h of x is equal to negative tangent. I'll factor out the 3, which will give me x minus pi over 12. And I put the plus 2 at the end just so that you can hone in on the fact that that's a vertical shift. Okay? Also, don't forget that this is a reflected tangent. So I am going to do all of the marks the same and everything, but instead of increasing, a reflected tangent is going to decrease. It'll look something like a cotangent. Okay, so let's get the period here. Right, the 3. So period is pi over 3, which means that my quarter period is 1/4 times pi over 3, which is pi over 12. Hey, that's interesting. Pi over 12 is also our shift. Coincidence. It's just a coincidence this time. I didn't realize that was going to happen. I just kind of made it up off the top of my head. No matter. It'll still work out nice. I'm going to put my axis way down here, though, because of the shift upwards. So I'll put my 5 marks on there. 1, 2, 3, 4, and 5. Okay. Now, tangent, remember, starts in the center. I've been shifted pi over 12 to the right, which means the center here is going to be pi over 12. Now, my quarter period is also pi over 12. So that means this is going to be 2 pi over 12 and 3 pi over 12. And then this one right here will be 0 because I'll do minus pi over 12. And then negative pi over 12. The 0 will be my y-axis. That's nice. I was shifted up 2. So 1, 2. And I have an amplitude of 1. Okay? So here's 3, 2, and 1. 2 is my new center line. Don't forget that. Right? 2 is my new center line there. I kind of slumped off at the end there. Ugh. Good enough. Okay. Then I have asymptotes on either end. So negative pi over 12. And 3 pi over 12. Okay. Incidentally, if you're not sure that these asymptotes are coming out right, don't forget that you could take these numbers like negative pi over 12 and plug them back into the original. 3 times negative pi over 12 will give me negative pi over 4. And then negative pi over 4 minus pi over 4 is negative 2 pi over 4, which is negative pi over 2. And tangent of negative pi over 2 is undefined. So this is, in fact, the correct placement of that asymptote. All right, so now let's put down the marks for the tangent. Don't forget, this thing is decreasing. This is the center. The pi over 12 was the center. So that means it's going to go through here. And then on the quarter marks, which happen to be 0 and 2 pi over 12, it's going to hit the amplitudes. So that's going to be here and here. So then the shape of my graph looks like this. like that. Okie dokie. Don't forget the reason why that one's going downward is because it was a reflected tangent. So let's finish up with domain and range here. Range is negative infinity to infinity. Domain is going to be everywhere x cannot be. Let's do 3 pi over 12, which is pi over 4, plus period is pi over 3 times n, and n can be any integer. Okay? So I hope this has helped you sum up, being able to graph all 6 of the main trig functions. So let's get a quick view of these 3 graphs. I have the 2 tangent 5 pi over 7x, which as you can see is already scaled on here for me. The asymptotes at negative 7/10 and positive 7/10 on the board were negative 14/20 and positive 14/20. Goes through the center, and as you can see, it hits that amplitude right at the quarter mark there, 7/20. It's the amplitude being 2. Okay. Next, let's go back to the standard view here and switch to the next one. Let's change our graphics view to having a distance of let's do pi over 24 and see if it's not too thick. That is pretty thick. Okay, so we'll stretch this out. That's not too bad. Okay, so then my asymptote right here at negative pi over 6 is what you would have already seen as negative 4 pi over 24. And the other one over here at pi over 3 was the other end. It does go through the pi over 12 in the middle. And then as you can see, it hits the half mark right here and right here on these quarters. Right here, because here's the center, right? And then my quarters were at the negative pi over 24 and at the 5 pi over 24 right here. Okay, so that's that cotangent one. Okay, so let's turn that off, go back to standard view again. Let's turn on this one, and this time let's switch our graphics to let's do pi over 12. That might work really well for this one. And let's shift the view. Okay. So as you can see, it was shifted upwards with a center line of 2 here. And then of course it hits the amplitude at 3 here and at 1 here. And the asymptotes are the negative pi over 12 and the positive pi over 4, just as we saw before. Okay.